Have you ever wondered who those giants actually were? When Sir Isaac Newton famously said that if he had seen further, it was by standing on the shoulders of giants, he was paying tribute to the pioneers who paved the way for his own revolutionary ideas. Today, we're focusing on perhaps the absolute tallest of those historical giants, a man whose relentless curiosity completely, and I mean literally, shattered centuries of unquestioned dogma, and in doing so laid the very foundation for our modern world. I am talking, of course, about the man who rewrote the universe, Galileo Galilei. Born in 1564, Galileo isn't just remembered for one single discovery. He actually holds this incredible collection of titles: the father of modern physics, the father of modern observational astronomy, and the father of experimental science. But beyond any single telescope observation or mathematical formula, Galileo's true genius was that he fundamentally changed the way human beings seek the truth. He taught us to stop just blindly accepting what we're told and to start asking nature directly. Okay, let's dive right into this explainer. Here is our roadmap for today. Number 1, the Aristotelian worldview. 2, the new scientific method. 3, rewriting laws of physics. 4, discovering the true cosmos. 5, conflict with the church. And 6, an immortal scientific legacy. All right, section 1, the Aristotelian worldview, 2,000 years of dogma. Now, to truly appreciate the sheer magnitude of Galileo's achievements, we first need to understand the intellectual darkness of the world he was born into. For almost 2,000 years, European science was effectively frozen. It was heavily based on the ancient philosophy of Aristotle. People believed these traditions as absolute facts without ever testing them. They thought Earth was the unmoving center of the universe, that heavy objects fell faster than light ones, and that all celestial bodies were absolutely perfect and unchangeable. Knowledge was simply dictated by ancient authority. Galileo, however, introduced a radical new concept: evidence. This directly contradicted those ancient traditions, proving that all objects actually fall equally, and that the cosmos is dynamic, and honestly, deeply flawed. Moving on to section 2, the new scientific method. A weapon for truth. So how did one guy manage to overturn 2 millennia of established thought? Well, he didn't just stumble upon new facts. He forged an entirely new weapon for finding the truth. Inspired by his father, Vincenzo, a musician and mathematician who constantly questioned popular beliefs, Galileo developed what we now call the scientific method. Instead of trusting ancient texts, he taught us to: Step 1, carefully observe nature. Step 2, form a hypothesis or ask a question. Step 3, conduct an experiment. Step 4, measure the results precisely. Step 5, apply math to understand it. And finally, Step 6, form a conclusion based strictly on the evidence. By making mathematics the language of nature, Galileo basically gave humanity a foolproof recipe for scientific discovery. Next up, section 3, rewriting laws of physics, from Pisa to inertia. Armed with this new methodology, Galileo turned his attention to the very laws of motion while he was a professor at the universities of Pisa and Padua. And it all started with a simple observation of a swinging lamp inside the Pisa Cathedral. He noticed that no matter how wide the lamp swung, each swing took the exact same amount of time. This little observation on pendulums was the first spark in his lifelong study of motion. Next, he tackled Aristotle's claim that heavier objects fall faster. Now, you've probably heard the popular story that Galileo climbed to the very top of the Leaning Tower of Pisa and dropped a heavy ball and a light ball at the exact same time. While historians do debate if this specific dramatic event actually happened exactly like that, Galileo undeniably ran exhaustive experiments on falling bodies. His groundbreaking conclusion: if you ignore air resistance, every single object falls at the exact same uniform acceleration. Today, we know this gravitational acceleration as 9.8 meters per second squared. But, measuring free fall back then was incredibly difficult because things dropped so incredibly fast. So Galileo created an absolute genius workaround: the inclined plane experiment. By rolling balls down a gentle slope, he essentially slowed gravity down just enough to measure it precisely. And the math speaks for itself. At 1 second, the ball travels 1 unit of distance. At 2 seconds, it travels 4 units. At 3 seconds, 9 units. Galileo mathematically proved that distance is directly proportional to time squared. He didn't just observe motion, he literally cracked its mathematical code. Building on this, Galileo tackled the concept of inertia. See, Aristotle believed an object's natural state was at rest. Galileo totally disagreed. He reasoned that without friction, an object in motion would simply stay in motion forever. To explain this, he offered this brilliant thought experiment. Imagine you're in the closed cabin of a smoothly sailing ship. If you toss a ball straight up, it lands right back in your hand, exactly as it would if the ship were parked at the dock. Without looking outside, you literally cannot tell if you are moving or standing still. This is Galilean relativity, the idea that the laws of physics are identical in any system moving at a constant linear speed. 3 centuries later, this exact concept would serve as the launching pad for Albert Einstein. How crazy is that? Which brings us to Section 4, Discovering the True Cosmos, Looking to the Skies. Having rewritten the rules of physics down here on Earth, Galileo soon turned his eyes upward. The year 1609 marked a massive turning point in human history. Taking a basic Dutch spyglass, Galileo engineered his own telescope, dramatically amplifying its magnification up to 20 or even 30 times. When he pointed this powerful new instrument at the heavens, well, the universe changed forever. The ancient dogma insisted the heavens were perfectly smooth and unchangeable. Galileo's telescope completely shattered this illusion. In a rapid-fire series of cosmic discoveries, he saw that the moon was not a perfect sphere at all, but was violently scarred with deep valleys, rough mountains, and craters. He pointed his lens at the cloudy band we call the Milky Way and realized, wow, it wasn't a cloud at all. It was made up of millions of individual distant stars. He even looked at Saturn and noticed it had these strange ears bulging from its sides, which later, more powerful telescopes would reveal to be its magnificent rings. But in 1610, he made a discovery that sent absolute shockwaves through the scientific world. Looking at Jupiter, he noticed 4 tiny points of light hovering around it. Over several nights of careful observation, he realized these lights were actually moving. They were moons orbiting Jupiter. We now know them as Io, Europa, Ganymede, and Callisto. So why was this so earth-shattering? Because if moons were actively orbiting Jupiter, it mathematically proved that the Earth was not the sole center of all cosmic motion. And the evidence just continued to mount. Galileo observed that Venus went through distinct phases, just like our moon, from crescent to full. The old Earth-centered model couldn't explain this, but Nicholas Copernicus's sun-centered or heliocentric model explained it perfectly. Furthermore, Galileo observed moving dark spots on the sun, proving that even the sun wasn't perfect and that it actually rotated on its axis. The facts were undeniable at this point. The Earth orbited the sun. Galileo's meticulous data presented a beautiful, dynamic universe, but it also presented a massive historical problem. What happens when undeniable new evidence directly challenges centuries of absolute established authority? That brings us to Section 5, Conflict with the Church, a clash of cosmic models. So we arrive at a major historical clash. In 17th century Europe, the Roman Catholic Church was an immensely powerful institution, and at this time, church officials officially supported the traditional Aristotelian, earth-centered model of the universe. So we have 2 directly opposing worldviews here. The geocentric model, representing the church's official stance, where Earth sits motionless at the absolute center of everything, and the heliocentric model, supported by Galileo's hard observational data, showing that Earth is simply another planet orbiting the sun. In 1632, Galileo published his masterpiece, The Dialogue Concerning the Two Chief World Systems. Though written as a debate between the 2 models, it clearly demonstrated that the sun-centered model was vastly more logical and evidence-based. As you can imagine, this publication sparked immense friction with the establishment. This friction culminated in the famous 1633 Roman Inquisition trial. Galileo was accused of supporting views contrary to official teachings. After a lengthy trial, the aging scientist was forced to publicly recant his support for the heliocentric theory, and he was sentenced to house arrest for the rest of his life. Legend tells us that immediately after his forced recantation, Galileo muttered the rebellious phrase, "E pluribus sumuove," and yet it moves. Now, historians do still debate whether he actually spoke those words aloud at that exact moment, but the phrase perfectly captures the undeniable truth of his discoveries. You can silence the man, but you absolutely cannot stop the Earth from moving. Which leads us to our final part, Section 6, An Immortal Scientific Legacy, the father of modern science. Confined to house arrest in his final years, Galileo faced an incredibly dark reality. His eyesight began to fail, and he eventually went completely blind. But while his eyes could no longer see the stars, his brilliant mind never stopped analyzing the physical world around him. In 1638, despite his blindness and confinement, he managed to publish his final magnificent work, Two New Sciences. This book summarized decades of his research. He broke down how thrown objects, projectiles, travel in perfectly predictable mathematical parabolas, combining horizontal motion with vertical freefall. He analyzed pendulums and the strength of materials. This single book essentially laid the foundational mathematical groundwork for modern kinematics and classical mechanics. So, what's the big takeaway here? Galileo's greatest gift to humanity wasn't just a single discovery. Ultimately, he completely replaced our reliance on blind authority with the power of measured evidence. He proved once and for all that mathematics is the true language of nature. Without Galileo's rigorous foundation, Newton's laws of gravity and Einstein's theories of relativity would have been nearly impossible to formulate. Literally every laboratory, engineering project, and space mission today relies heavily on the framework he built. Looking back at his 77-year journey, born in Pisa in 1564, he shifted from medicine to math. By 1609, he upgraded the telescope. In 1610, he discovered Jupiter's moons and radically expanded our universe. He courageously published his dialogue in 1632, faced the Inquisition in 1633, and finally passed away in Archetri in 1642. In a single lifetime, he basically dragged human understanding out of ancient philosophy and firmly into the modern scientific age. Which leaves us with a truly fascinating question to end on. If Galileo Galilei was able to change our entire understanding of the universe simply by daring to observe it differently and refusing to blindly accept the status quo, what established, unquestioned truths in our world today are simply waiting for someone like you to step up, look closer, and start questioning them? Thank you for exploring the mind of this giant with me today in this explainer. Keep asking questions, keep looking for evidence, and never stop learning.